welcome everyone. Today's seminar, we have Dr. Chen Xu from Swansea University. She is a lecturer in the Swansea University. And previously, she works on a super fast broadband project focused on estimating the impact of technology adoption in the Welsh region. And now she is working on an ONS funded project called Measuring the Digital Economy. I think the paper presented today is called Measuring the Regional Digital Economy. I think this is a really important topic, especially when the government now is trying to achieve leveling up through R&D investment. So really looking forward to the presentation. And as always, please keep your questions until the end. We will leave around 15 minutes for discussion, and you can just type them into the chat or just raise your digital hand. And now I will hand over to Dr. Chen Xu.
Thank you. Can I share screen, please?
Sorry, before was Sarah helping us doing this. Does anyone know how I can allow Dr. Chen to share her screen?
I think
yeah, just make her co-host.
So how, okay. Yeah.
Yeah, the share screen has a multiple, yeah.
Yeah, thank you.
Can you see my screen? Okay, good. I can see there are people like entered the waiting room.
Yeah.
Yeah, should I just ignore that, right?
Yeah.
Okay.
I will take it then.
Okay. Yeah. Unmute. Yeah, hello everyone. Yeah, we have a small nice group today, so I'll just keep everything brief, and hopefully we'll have enough time to discuss in the end. And my name is Chen Xu. I'm a lecturer in economics at Swansea University, and I'm also an honorary research fellow at Welsh Economic Research Unit in Cardiff University. And today I want to introduce our research project on measuring the regional digital economy by compiling a pilot information and communication technology ICT satellite account for Wales. And this project is funded by ONS Research Fund. And I'll start with the relevant digital economy literature with reasons of why we need a satellite account measurement approach, and also the reasons of why the earlier ICT satellite account framework proposed is not used in this project. And for the methodology, I'll start with introducing the tourism satellite account methodology, because the ICT satellite account approach for this project is very similar to the TSA framework. And then I'll show the actual tables of the ICT satellite account and briefly introduce the steps for estimation. And with the key results highlighted, limitations emphasized in the end, and hopefully we will have time to discuss the questions we have. And so In the literature, the importance of ICT products and services have been studied at various sectors and also from different perspectives. In agriculture, for example, ICTs not only improve the production, the sector production, but also it acts as tools in getting the most updated agricultural knowledge and skills, especially in the remote areas. And in the business sector, ICTs are enabler of advancement, source of innovation, and they provide opportunities for performance improvements, markets expanding, facilitates the application of other technologies as well. And from the social perspective of the impact ICTs bring to the society, a recent study provided evidence that within the existing social and environmental conditions and arrangements in New Zealand, ICT use contributes to the refugees' social inclusion. The explanation has sufficient generality to be useful in other contexts. And at national regional level, ICTs improve economics total factor productivity by enhancing productivity and inspiring innovations. And digital investment is often accompanied by human capital investment and the organization's structural change. Therefore, the returns on the ICT investment are often higher than the physical investment. And there are also evidence being provided that the productivity in Europe and US diverged during the mid-1990s. This may largely because of the strong investment in ICTs in US. When the capital intensity of ICT in Europe began to fall behind, this is the same time when US productivity growth was increasing rapidly. And in recognizing the importance of ICTs, different countries have various policies and strategies in place to maximize the adoption of the ICTs and its impact on the productivity growth. Here are a few examples. And in the case of Wales, because this project is based on Wales for the year 2018. So in the case of Wales, Welsh government has a superfast project, which is 425 million. It's partly funded by European Regional Development Fund, which was launched in 2013. And it aimed to ensure that 96% of the premises in Wales have access to superfast broadband by end of 2017. And our research unit, Welsh Economic Research Unit, it has done a 5-year study, which was part of this project. And some of the data I used to estimate the numbers on the ICT satellite account are from this project, which I'll explain more later. While the majority of the studies have shown that ICTs are positively and significantly affect firms' productivities, their studies have highlighted the methodological and results differences. And the aggregate and sectoral growth suggests stronger differences, while firm level and analysis suggests no significant country differences between US and Europe, for example. So a measurement that is consistent with the system of national accounts, SNA, might be useful because it is more comparable across sectors. And more importantly, it may be able to effectively measure ICT's penetration across all sectors, because ICTs are involved across all the sectors nowadays. So the satellite account approach, it provides a framework linked to the central account at national or regional level. In our case, it's regional level. It's allowing attention to be focused on a certain field of national accounts. The common examples for the satellite accounts as the environmental or tourism. And here, in the next few slides are the ICT satellite account framework proposed earlier, and this is the ICT satellite account framework proposed by OECD in 2018, and the nature of the digital economy is divided into digitally ordered, platform-enabled, and digitally delivered. And specifically, it has 3 matrices about investment, production, consumption. However, the data, the information on these matrices, for example, products B, digitally ordered, physically delivered, digitally ordered, and digitally delivered, and information like this, data like this are not available so far. So this framework is not feasible at the moment. Maybe in other countries or places, but not feasible in the UK yet. So we needed to think of other feasible framework based on the data available. And then the second one is the ICT satellite account framework that's proposed by Statistics South Africa in 2012, and I have 2 tables that are similar as this ICT satellite account framework from South Africa. It's based on the output and trade information by the ICT specialized products and services. But what we think which are more important is about the reconciliation between the supply and demand of the ICT products and services. So that's the difference between our framework and this framework proposed by the Statistics South Africa. And then the last one about the earlier proposed satellite account framework is this one proposed by the Federal Statistics of Germany and in 2007. And probably because this was proposed before 2011, that's when the OECD published the guideline on measuring the digital economy in terms of what the ICT products and services are. So the products categories and the industry categories are much broader than what we have for the ICT satellite account in Wales in 2018, which we will see in a minute. And on the methodology, I'll introduce the tourism satellite account framework first, because all the features, the standards that apply to the tourism satellite account, TSA, they would apply to the ICT satellite account framework we will use for this project. Why TSA is a useful measurement for the tourism industry is because the complexity of tourism industry. Tourism covers many established industry sectors, but it is invisible. It's not an industry in the system of national accounts. Therefore, TSA is established to measure the economic contribution of tourism in the ways that's consistent and compliant with SNA. And in order to make the measurement of the aggregated amount of tourism-related activities across the whole economy, we have to identify each existing industry sector and search for the amount of the tourism-related consumptions that's hidden in the sales of these industrial sectors. So TSA is not a model of economic activity, but accounting to record the tourism supply and demand direct annual values. And the key is it links and reconciles the tourism product supply and demand and provides a similar definitions and approach to those used to measure other economic activities. So TSA provides a possibility to compare the tourism with other areas of economic activity by its economic contribution. And the standards that distinguish the TSA as a measurement approach from other tourism measurement approach is it elaborates the interconnected tables as accounts, which are consistent with the supply and use tables of SNA, and it also excludes the indirect, induced, and multiplier effects of the tourism. So it only limits to the measurement to the direct economic contributions. And the data for the tourism specialized products and services are provided, and it prevents the four major macroeconomic aggregates, the expenditure, consumption, GVA, and GDP. And specifically, it comprises 10 tables. Not all of those would be always estimated, and most often the first 7 would be estimated. They show the size and the distribution of the tourism consumption and their contribution to the national income, employment, and other macroeconomic measurements of a nation or a region. And these are the 10 tables for the tourism satellite account. And these 4 internal consumption, production accounts, and the reconciliation between supply, demand, and employment contribution. These 4 tables, the framework would be, we would use it for the ICT satellite account. So the project, the ICT satellite account WELS 2018, it aims to construct the pilot ICT satellite account that mirrors the well-developed TSA framework. The first stage is to compile the WELS input-output use tables 2018, and I'll explain why we need to do that in a minute as a first stage. And then the second stage is to compile the 5 tables for the ICT satellite account. And table 1 is on the ICT shares of GDP and GVA by industry in Wales in 2018. And table 2 shows the trade of ICT products and services. It's an interregional trade in the UK and from the rest of the world. And table 3 is on the ICT products and services consumption account. And then table 4 is a reconciliation between supply and demand, and it's a key table to provide the ICT ratios. And then the table 5 is to multiply ICT ratios to the employment and the GVA to have the direct contribution of ICT products and services consumption on employment and GVA. And this is a very data demanding process. So I relied on both the ONS Secure Research Services data sets and the public data sets as well. And with the ONS Secure Research Services SRS datasets, I have requested the following ones, and it took quite some time, and to go through like all the procedures so I could access the data. And the 2 major ones, which I draw the most of the information for the satellite account, is the ABS, Annual Business Survey, and the Annual Purchase Survey, APS. And the rest of them, I use them to adjust the estimation or as a supplementary information where needed and appropriate. And for the public data sets that are most useful are the following ones. The ONS regional accounts provides the total GVA numbers, and the stats WELS data. They initially, these data are initially from the ONS dataset as well. So from the stats WELS data, I looked at the GVA, the business size information, and with the UK SUT and Scotland SUT 2018, they are useful to adjust the ABS data set with the ratios, especially the Scotland SUT 2018 is preferred most of the time because it provides more details, and also it provides the interregional trade, the trade between Scotland to the rest of the UK. This information is not available elsewhere, and I adjusted it to Wales. And then the final demand estimation is based on the Wales IO table 2019. This is a 64 sector our tables, and the final demand is estimated based completely on public data set and the earlier version of Wales our table, and also other projects data, the data from other projects in the research unit. And then the business register and employment survey data. This one provides the detailed employment data sets. We will see in a minute, although I have lots of data sets, but it's never enough. So when there is not enough detailed data available, I apportioned the aggregate mostly by employment, and the employment by the 4-digit SIC number standard industry classification is very useful. And then the digital maturity survey 2017 to 2020, this is useful for estimate some key information as well. And this is, as I earlier mentioned, it was part of the Welsh government superfast broadband project. And there were some other data that were useful as well from the team. So the reason why I needed to start with compiling the Wales input-output table 2018 as the first stage is because the two-digit IO tables for Wales the most recent one is 2007. So first of all, I needed to update the information, and then another thing is, following the guideline from the OECD, the document that's published on Major Reason Information Society, it has a guideline on what the ICT products and services are. It's defined by the 4-digit SIC number. So the first four categories are ICT goods, and then the last 5 categories are ICT services. So in order to compile the ICT satellite account, I needed ideally I needed IO tables that has two-digit industry level plus the additional 4-digit industry and products classifications in these categories. So I tried to compile the IO tables first with 2-digit as a start, and then additional 4-digit industry level. So this is product by industry, additional 4-digit level, following the restrictions of the ONS-SRS data clearance restrictions and the data availability restrictions itself. So wherever possible, I would try to have a 4-digit industry consumption on the products. And then this is a structure of the Wales IO table 2018 method 18, and I'll briefly go through how I compiled it. So started with the GBA from the ONS regional accounts, and then for the ratios of the GBA components, consumption, output, these data are from ABS, from the ONS Secure Research Services. And when these data don't look right, when check these figures against the public information, the UK SUT and Scotland SUT ratios are used to adjust the ABS data. And then between these two, between the UK and Scotland ratios, the ones that's closer to the ABS ratios would be the preferred one. And then in other cases, for example, the imports from UK, import from the rest of world, this information import from UK, these ratios would be only available from the Scotland table. And how that was adjusted, I'll explain it in table 2. And then the top left corner, once we have the total domestic use, and then the top left corner, we have the purchase ratio by each industry, either two-digit SIG industry or four-digit SIG industry, and the consumption of the products ratios are provided by the annual purchase survey, and apportion these total numbers by the annual purchase survey ratios, and then we have a top left corner, and then on the right corner about the final demand, I have just explained in the data section that was from the Wells Our Table 2019, that is 64 sector, but it provides very useful information in these estimations. And then the following ones are the actual ICT satellite account tables. Table 1 is the ICT share of GDP and GVA by industry. These are the ICT specialized industry, other industry. And the industry output and gross value added, these ones, they are from the use table, the column totals. When, for example, the 2630, this information is available in the IO table. So that can be used directly. And for the information that's not available, for example, 58 is only available, 5820 is not available due to the clearance requirement or data availability, and then it will be apportioned according to the employment proportions. So the ratio of 5820 as a proportion of employment in 58 two-digit industry classification, and multiply that ratio to the total industry output of GVA of 58 column totals, and that would be the industry output and GVA, and how this is how the key information of how this number are estimated. And then the second table on the trade of ICT products and services, the key information here is for the products export in products and services export and products and services import. This information are available from HMRC and some other data source as well. But for the interregional trade, these data are not available elsewhere. So the export and import from and to Scotland, this ratio is used, and then by compare the relative importance of a certain industry in Scotland and Wales. For example, for industry A, and the employment in Scotland as a ratio of the this employment in industry in the rest of the UK, calculate this ratio first, and then calculate a similar ratio as the employment in industry A in Wales and outside Wales, and compare these two ratios to see the relative importance, and then adjust the products export and import accordingly where appropriate. And that's the key information of this estimation for the table 2, the trade information of ICT products and services for Wales in 2018. And then the next one, this one is for the, this is a consumption account of ICT products and services by ICT specialized industries plus all other ICTs, no ICT specialized industries. These numbers, again, either they are available. Actually, it's like the most part of this data are not available directly from our tables because they require a lot of details. And when they are available, it's used directly. When they are not available, again, the employment from business register and employment survey, the proportions are used. Or the product column, the industry production of the certain products in 4-digit product code with appropriate assumptions and approximation, and these this consumption of the ICT specialized products and services by this industry are estimated. These are in 4-digit SIG number, so there were a lot of approximations and estimations. And then in table 4, this is a key table. It's between the total supply of the ICT products and consumption of the ICT products and services, the reconciliation of this supply and consumption, and where we get the ICT ratios. So the domestic product output at basic prices. This one, again, the information is provided by the IO tables, because I compiled 2 versions. One is the combined use IO tables, and then another one is the domestic use IO tables. So this is from the column totals of the domestic use IO tables, and then with the column totals of the domestic use tables, that is the industry supply, and this requires the product supply. So with the product supply and industry supply, I converted it again from the Scotland tables as the product supply as a ratio of the industry supply. And there may be other better ways, but that's like the best way I could think of when I compiled this. And then these products import from the rest of the UK, from the rest of the world, they are from table 2, as we have just seen. And taxes less subsidies on products are estimated in a similar way as column 1. Then the total supply as purchase prices is the sum of the first 4 columns. And then total ICT consumption and purchase prices, these are from the table 3. So the ratio of consumption as a ratio of the total supply, we have ICT ratios here. Here, the most difficult part is all other products and services. So among all other products and services supplied, what's the ICT consumption at purchase prices for those? This is difficult to estimate because it's not visible. It's invisible in the national accounts. For example, in the universities, I'm sure in each university there's a dedicated IT team. They deal with our daily IT requests, and they provide IT services, and we as staff, we consume them. But they are more complicated, like IT services that supports the education services the university provide. But in national accounts, they are probably classified as education providers. So in order to estimate this part, that's in every institution or business where there is this ICT products and services provided and consumed, but doesn't appear in the national accounts, the Digital Maturity Survey from Welsh Economic Research Unit is applied. This is a 5-year survey that we collected data on 40 ICT items across 5 dimensions of ICT use, ICT infrastructure, investment capabilities, digital use, and e-commerce. And across each item, like lots of details are collected. And among these details we collected, the information that could be useful for this estimation are these 2. And the information I used for this estimation is one of the question we asked is, does the business employ ICT specialists? We asked about the internal ICT specialists and external ICT specialists for different purpose. And then I calculated the number of ICT internal specialists employed as a total full-time equivalent employees. And this ratio is is 5.43%. So assume the consumption of the consumption of the ICT products and services for non-ICT industries, because the estimation here, we have collected the industrial information as well. So this calculation estimation was done for non-ICT industry only. So for non-ICT industry, we assume the ICT products and services consumption is consistent with the ratios of the internal ICT specialists employed. So therefore, that's the estimation of the ICT ratios for all other products and services, and then add all the consumption for ICT products and services and all other products and services together as a ratio of total products supply, and we have a ratio of 8.03%, which means around 8% of the GVA, for example, could directly contributed because of the ICT products and services consumption. And then once we have the ICT ratios from the table 4 and multiply these ICT ratios to the employment, full-time, part-time, and full-time equivalent calculated, and employment from the business register and employment survey, and we have the ICT direct employment, and multiply this to the GVA from table 1, that's the ICT direct GVA. So it's the GVA and employment that were contributed to the Welsh economy as a result of the direct consumption of the ICT products and services across all these industries. And also the productivity of each industry, ICT industries and non-ICT industries are calculated. We can see almost all the ICT industries, they have higher productivity in terms of the GVA per FTE, full-time equivalent. They almost all of them, they have higher productivity or much higher productivity than other industries. And so because this process is very data demanding and it provides a lot of information, so it is quite information intensive. And the key results we could draw from it. For example, in total, ICT products services directly contribute to 8% of the GVA in Wales in 2018. As we have just seen, the ICT industries have higher productivity in terms of GVA per FTE compared to other non-ICT industries in Wales in 2013. And again, among all the ICT industries and the miscellaneous ICT components and goods and information technology consultants and services, these two are the two ICT specialized industries that have the highest productivity in terms of GVA per FTE in Wales in 2018. They are the example key results we could draw from this ICT satellite accounts we compiled. We could always draw other results or information from these tables, and depend on the purpose. And for the limitations of this framework, as I have mentioned, it's a very data demanding process. And although I had lots of data resources, and but there were a lot of approximation assumptions made, so I could complete the complete estimation. And also the framework that is different from the framework suggested by OECD, as we saw earlier. And because the framework that's suggested by OECD is not feasible for most of the countries at the moment, so the ICT satellite account framework varies across different countries. So they are not widely comparable yet. And also the data and the classification of products and services may slightly vary across different economies. So this is not widely comparable yet. And that's all what I want to say about our projects. And I would be happy to take any questions you have. Thank you.
Any questions?
Hi, Chen. Thanks. That was really great. It was really interesting as we're considering our own extensions to our impact tables, and IT is not one that I'd considered. It's not one I'd really heard about. You mentioned tourism. It's obviously a very sort of the gold standard for this kind of thing, and we might consider environment or possibly the creative industries, which is quite relevant because one of your major sectors in the ICT account is IT consulting activity. So it's interesting to see that you've got sort of almost half of the creative industry is already disaggregated in that sense. Just listening to the presentation, I thought the results you've sort of revealed, they give obviously granularity down to these 4-digit SICs for things like GVA per FTE. I suppose they seem quite, I mean, obviously they're relevant, but what do you see as the sort of policy consequences of this granularity? What do you think this sort of new information might be used for? How would you sell it? Or is it, or, you know, is it more of a methodological exercise?
As I just mentioned, for the limitation, because of the data scarcity, so a lot of approximation and assumptions are made for those estimations. So I'm not claiming the numbers here are accurate, but it is a useful. It's probably a useful measurement tools for the ICT, measure the ICT products and services overall contribution to a region. And especially like if we have like a reliable data set and estimations, and with the supply and consumption information goes down to the 4-digit level, that is consistent to the OECD guidelines. And perhaps in the future, when these are more comparable across economies, and I would think it would become more and more useful, like a policy-oriented policy suggestions. Yes, that's my thoughts. Yeah.
So you think it's possibly just too soon? It's because you mentioned it at the start, some interesting stuff, you know, links to agriculture where they have maybe more of an interaction with IT services. They see higher productivity. It'd be interesting to, you know, look into what relationships you found. Did you find that there was, you know, sort of an interaction with agriculture or other sectors? I suppose you might need time series for that. That
is not possible with the current data availability. The major restrictions is because of the APS data only started in 2015, and the most recent one is 2018. So it only has 3 years data set. I don't think the time series is possible yet, and but that is very necessary. But that is like a data set we have to use, so we would know the reliability, how reliable the industry for certain products and services. So that's the issue. I don't think that's possible yet. Yeah.
Yeah. Just one more.
Yeah.
I suppose what was this a you know, I know this is something you've been looking at for a little while, especially as you had the digital maturity survey. Is this project done now, or do you intend to expand it in one way or another, or explore different satellite accounts? Or
did you mean with the digital maturity survey? Is it is a Welsh research unit? It's carry on with study, or it's already done? Is that what you mean?
I mean, specifically with the ICT satellite account. Once you publish this with the ONS, are you sort of finished with this, or you know, what will you do next?
Oh, I think they would want quite a technique report, and we would after that we would write a paper with ICT satellite accounts framework that's probably more like policy focused, and like an academic paper based on this project. Yeah.
Great.
Any other questions? Yeah, Ed, please.
Yes, thank you for that. I mean, I think what this highlights in part is you know, I was impressed by the level of detail you got there with this. The data relates to, I think, 2018, and clearly something like IT keeps on developing. Do you have a sense as to sort of how dated this sort of work becomes over time? If that isn't I don't know whether that's a sensible question or not, but it's something that struck me listening to you about it.
Sorry, can you explain what do you mean by data?
Yes.
Sorry, can you say your question again?
No, I found it very interesting, and the amount of disaggregation, as Matt highlighted.
Yeah.
Clearly, for this sort of work, you're relying on historical data. You know, you're using the latest data available at the time. But I'm thinking in something like IT, that's a sector that, you know, there's ongoing developments within. And I just wondered, with this kind of work, how dated or how out of date, you know, this becomes. How long is this sort of, would you say this is current for? And might that be, and how might that impact on the results sort of going forward? You know,
I think with the data availability, I mean, especially like COVID happened between 2018 and now. I think this with this estimation for this specific case, it might be not that outdated, because not much happened in between. But in normal times, even like much happened in between. But this framework is it still provides the key information is about the ratio. It's the consumption and it's the supply. The consumption and supply most of the time is probably going up together, and the ratios still have some use. That's what I would think. Sorry, would that answer your question? Or
yeah, that's great, Chen. I suppose just another question in general about the Welsh input-output tables. I didn't know whether you knew any more about what the future of those are, because it looks like you've compiled the table for 2018.
Yeah. Calvin compiled a 2019 one, but it's in 64 sector. He has a symmetrical table, so probably easier to use. And I have 2018, but it's for the use table only. For the supply information, probably needs some estimation and additional information. Yeah, and I think Carver may be thinking of like publish the 2019 64 sector symmetrical table, because he's using it for carbon footprint project at the moment.
Great, thank you. I think you're muted, Pei.
Okay, so are there any other questions? And if not, then I would like to thank Dr. Chen again. Thank you very much for this great presentation, and we learned a lot from it. And we will be back with the seminar in 2 weeks' time. And next time we will have Makala Triple from University of Vienna. So hope to see you in 2 weeks' time. Thank you, everyone.
Thank you very much. Thank you for listening. Bye.
Bye. Thank you.
Bye.
Thanks. Bye.